Right, so let's pick up where we left off yesterday. All right. So yesterday we wanted to be able to identify. Where is it? At least 5 principles of functional programming. So, before we dive in, let's see how well you retained the stuff from yesterday. From memory, without looking at your notes, I want to see if you can list 5 principles of functional programming. It's okay if you don't get all 5, but we got to prime our brain that this is important. So 1 minute, see if you can write all 5. You can also add any of those like bonus ones that we talked about kind of at the end. Dance with my baby, dance with my baby. Okay, cool. So the list we worked on yesterday was this. So next thing, if these are 5 of the principles that we want to talk about, also gonna have closure in there. Then you go to a lame Thanksgiving party, somebody asks you what all 5 of these mean, what's the answer you're going to give them? So I want to take, let's do 3 minutes. I want you to come up with your best definition for all 5 of these. Not looking at your notes. Straight off the dome. Oh, I need more warm Diet Coke.
I'm not going to that Thanksgiving party. That sounds
Kyle and CJ can party on their own.
Say you need to get a drink. Asking these questions.
Fuck, okay.
There are 30 seconds. All right. So let's work through this as a class. Mez, what did you get for purity?
Functions that don't take in outside variables.
Yes. Let's be careful in the language of this, because like the variables always come in from the outside. I gave you a specific vocab word for this. It's 2 words. In. Der.
Oh. I have it written down.
Indirect input. So indirect input is if a function is something that takes in inputs and turns it into an output. Indirect input is something that we're just referencing it from over here. It doesn't actually get passed in, but we're still using it. That's indirect input. One other part of purity though. That's half of the equation. The other half is, well, that's part of it, but it's the same sort of thing. If in the process of generating this output, it also fucks with something over here, it's not indirect output, it has a snappier name, side effect. No side effects. No indirect input, no side effects. And then one other thing that relates to predictability that isn't specifically in either of these categories, but we call it deterministic. There are 2 really super duper common things that you can do in your functions that make them not deterministic. Guess what they are? Super common. You've done them in this program before. But the things you commonly use in functions that generate not the exact same output every time.
Changing variables?
Nope. If we had a function that like shuffled cards or something like that, how would that work under the hood? Yeah, what's that? Random number generator. So it's not predictable number generator, random number generator. So things that use random numbers are not deterministic, and therefore they're not pure. One other thing in that category. What?
I was just gonna ask, so in functional programming, there's no shuffle cards, no random numbers?
There is, however, we isolate that. And so random number generators, like the ones we use in computers, are not random number generators. They're called pseudo-random number generators. They follow an algorithm, but it'll do it based on a seed value. So given some seed value, I end up with this random number. And then that seed value is generated by an atomic clock, or a really common one is atmospheric noise. It'll just turn that into binary signals and use that to seed values of the random number generator. But you should get the exact same number with the exact same seed. And so what you do is you make the random number generator one of the inputs on this. Given this random number generator with this seed, I'll produce a predictable output. So we're isolating the randomness. Great question. Cool. What's the other one? It's even more common than that. I can scarcely think of like many useful apps you could make in the modern age that don't have to use this. Here's your hint. Time. Things that have to do with dates, time elapsing, even something that just uses like, what time is it now? That's not deterministic. And in functional programming, you saw that the exact same way. Instead of just relying on date.now or new date or something like that, you pass that in. So if I'm given this particular date, then my outcome is deterministic. Okay, that's purity. Stacy, what did you get for first class function?
I remember something about primitive.
Mm-hmm.
I don't remember what it means. Where there maybe like you can put a function instead of another function.
Not quite. That's related.
Argument.
It's the reason that you can pass a function as an argument to something. Who can help Stacy out? What's a first class function? We got primitive. Functions are primitives.
So they're treated as like strings or
The same as
Same
strings,
as strings.
Booleans, anything else. So that means we can store them in variables, we can pass them into functions, we can return them from functions. Anything you can do with a Boolean, you can do with a function. That's a first class function. Okay, Diana, what'd you get for immutability?
Once you assign a value to something, the value won't change, and then state cannot be changed after it is created.
Yep, pretty good. Does const, is that immutability?
No,
Why is it not immutability?
because you can declare a constant within a function. And so like global const could technically, I guess, count as immutability, but const within a function is not.
So you're in the ballpark, but we can absolutely declare const inside of a function, and then when that function gets called again, none of that exists. That's fine. And if I do something like const a equals true, and then set a equal to false, I get an error. That's immutable. What about if I do now, I've given B, I've changed B, I've mutated B, even though I declared it const. That's not immutable. Close. The real way, the way you would do this in functional programming is you'd say const functional B equals array, and then I'd do const new functional B equals spread functional B, and then whatever the new value is. And now new functional B was never mutated. Functional B is still exactly what it was before. But I use that to make a new value. That's how we do like array and object kinds of operations with immutability.
So no dot push.
No dot push. Dot push is a mutating method. Not allowed to do those. So go ahead.
Are you allowed to do non-destructive methods?
Mm-hmm. So I can do something like new functional B dot length. That's non-destructive. I can do map. Map doesn't change the original thing that you're operating on. It just returns a transformed one. But push is destructive, pop is destructive, shift is destructive, unshift is destructive. Not allowed to do those in FP. Cool. That's immutability. Let's see, Samantha, what is referential transparency?
I want to say, isn't that when you can use
like, having to use the original or something like that?
Oh, you're so close. Like 70% of the way there. What's the other 30%?
Like you can use a function as its value, as its return value.
Correct. You can use any expression as what it evaluates to. So if I make a function called returns 3, and all it does is returns 3. Oh, because I mix and matched. Okay, so I've got returns 3. Returns 3. If I invoke it, I can do everything that I can do with 3 with returns 3, because this expression evaluates to 3. So these are equivalent. I can use them interchangeably. In practice, that means things like if I was doing const sum array equals 1, 2, 3, and then doing sum array dot map and doubling it, cool. I didn't need to save it in a variable first. Because if these two things are equivalent, I could have just put this there and it'll do the exact same thing. So like, and there you go. What things evaluate to and those expressions that we're evaluating, interchangeable. If you can use one, you can use the other. That's also why we can chain these methods. That's why I can .map, .filter, .filter, .map, because the thing they return is an array. I can call that on an array, ergo, I can chain these things as long as I want. Powerful idea. Okay, and then Toby, what's disciplined state?
I totally forgot what discipline state was.
Awesome. Anybody remember why we talk about disciplined state?
I said no global variables.
That's true. We'd never have global variables. So state is kind of the, go ahead.
Like state local, like within the function, like kind of scoping state.
So it sort of goes along with purity, where we don't want any, state is the enemy in FP. We're trying to have no state. Because if we have state, now we have more places that things could break. Because we have a previous state and an after state. And then an after state, and then an after state. So we're trying to minimize state as much as possible. But truth be told, there's no getting away from it. At some level, we're saving variables and we're doing loops and we're doing all this kind of shit. But if we can wrap it up in a package where none of that state escapes, then we're okay. Dinah?
Yeah, I'm just gonna say, like, keep state local.
Yes. And just as small as possible, even like within a function. We're trying to keep our functions teeny, tiny. And so the lifetime of any state we're using should be very brief. And like state is like a big, scary computer word. We're talking about variables. That's it. Properties on objects. Anytime you're using const, let, var, that's state. Instance variables on methods or not objects, state. Okay, so that's a review from yesterday. So let's get hands-on. I posted this code in the announce channel. No, I posted it in the Hash Clears channel. So our goal is to take this code and refactor it until it has no declared variables, no mutable state, pushes side effects to the end. So like, this bears a little bit of explanation. So we say we don't want side effects. They're bad. Well, a program with no side effects doesn't do anything. Because at some point we need to like see the output. We need to change the world in some way. So we need a side effect at some point, but we want it to be at the very, very end. Everything else we want to be pure data transformations. Pure functions and no anonymous inline functions. That's when we're using a fat arrow to pass in a function to something like map. Extract that out to a declared function and pass it in. All right, so that's our goal. I'm going to give you 5 minutes to wrestle with this, and then we'll do it together. Yep. I'm almost positive you're at those. They're using Lodash. Correct. Not on that board for this time. No, it's the first argument. It's actually the only one that's required. All right, back together now. So, tell me about some challenges you faced doing that. What was like, got it right away? What is like, how the fuck would I do that? Yeah.
I thought that the figuring out how to do a for loop some way
Mm-hmm.
was a little bit difficult.
I like that. How did we get around the for loop thing? Because for loops are mutation all over the place. This I keeps changing every time. That's not very functional. Map. So map, filter, reduce are like array applicatives. We use those instead of for and while loops exclusively. So if I were going to do this as a map, it would be something like teachers.map teacher, and then I need to do all of the things. Actually, we can even start as a for each. And then we're doing the same thing, which we can prove by, there we go. If I run that, awesome, I get a bunch of loud teachers. So the array applicatives pull us out of that. Mez says map for this. What are the steps to turning this for each into a map?
You said that in map you can't have a fat arrow in there?
Ultimately, we're okay for right now. So we get to write it that way. We just don't want to leave it that way.
With this one, don't you just change for each into that?
Okay. Yeah, and that'll,
The syntax is the same.
yeah. Now if I do that, well, still have that temporary variable, but it works, does the right thing. There's something weird about this though, because I'm using this little placeholder variable up here each time still. Starts as an empty string, and then each time it becomes the right teacher.
Yeah, you don't actually need the allowance.
Okay. So I can localize this. I can discipline the state like that. Okay, that's still working. What else?
Do you take the entire loud teacher console log thing out and make it a function?
Ooh. Yeah, so what if I called that function shout that takes in a string and just console logs it? Okay.
Now you have to bring the teachers inside too, because you can't.
Am I gonna? What do you mean by bring the teachers inside?
Wouldn't you would wrap like the teachers array and the map together into a function
Oh yeah, we can do that.
so that it's not outside the scope.
Well, like this will work as is. Actually, don't need to change anything right now. If I run that, they're all still there.
You're still assigning
But
variables.
it's not functional, right?
Not yet. See, has no declared variables. We've got two. We've got this and this.
So to get rid of the teacher's variable, I just use the array map.
And do that directly? Yeah, and we can do that because of referential transparency. Dope. So we got rid of one of them. Does it still work? Oops. It does. Okay, so we still have one declared variable. That was pretty easy to get rid of. How would I get rid of that?
Your lab teacher.
Yeah. Yeah. Put that entire expression inside there. And I can do that because of referential transparency. Cool, still works. All right, so I have no declared variables. I have no mutable state. I have not pushed side effects to the end. I do not have pure functions, and I do have an anonymous inline function. So get me to the next step.
Can you make the teacher plus exclamation
Mhm.
point its own function?
Yeah. So maybe I call that Loudify. It takes in a string and it returns string plus exclamation point. And I shout Loudify teacher. Does it still work? Still works. So the thing that I just did, referential transparency again. The string that this returns is just like I typed that string in there. So I can pass that into shout. Cool. What else can I do to help meet these requirements?
So you're calling functions in the first one that are outside of the scope of it, so
That's fine.
that's fine.
That's fine. In the same way that like in OOP, all those classes just get thrown into a namespace, we can use the classes anywhere. We can also do this with function declarations. These are out in the ether. However, if you do super want to be strict FP about it, we can do const shout equals like that, and then like that. What's going to happen when I run this? Yep. And
They need to both be above the.
but that'll work.
Was the S6 added to JavaScript because to make it like more functional?
That's funny. You would think that, except that's also where we got the class keyword from, and static methods, and all this other kind of shit. It was to make both people happy. It was like, what if it were more functional? What if it were more OOP? You got your chocolate, my peanut butter, and we've been going down that road ever since. We've been getting every time we get something cool and functional, we also get async await, which is very OOP-ish.
So, sorry, why is it more functional to assign a variable to the function?
Because they don't hoist. There's less scope fuckery when we do that.
So hoisting is less functional. Okay.
I love hoisting. That's my preferred way to do it, but it's a fight that I'm losing. So get used to seeing it this way. Cool.
Isn't teacher technically a variable?
It's not a declared variable.
We still don't like we'd rather have a function in the map.
Indeed. So what do I do?
So you call Loudify
Mm-hmm.
and give it a argument of shout.
So we're trying to extract this fat arrow function out. What would that be called? Actually, hang on. Before we do that, before we extract that function, one of my beefs is that we haven't pushed side effects to the end. on every iteration, so the side effect in this case is the console log, outputting it to the screen. Anytime we're outputting something to the screen, that's a side effect. So we're going to do that very, very last. And right now, we map over this, we're seeing Kyle. We output Kyle. Then we're loudifying Potts, and we console log Potts. And then we're loudifying Damon. So we're going to split those two responsibilities up. Also, this is always a red flag. We're mapping, which is data transformations. We're not returning anything. So nothing was actually transformed. So what I probably want to do is split up those operations. How do I do that?
You can return modified and pass it into shout.
All right, I like the way you think. So if I return loudify teacher, what do I do with shout?
You can pass in modified teacher into shout.
Did you just call shout after the?
But I have an array. I need to call it for each one.
Oh. Yeah, like in the assignment.
But I've returned it. I've done the transformation. So right now, this is going to evaluate to each of these strings with exclamation points on them.
Can you make that entirely into a const? And then call it?
Yeah, good.
shout?
But shout doesn't take in an array. It takes in a string. But yeah, I could say const loud teachers is that. But if I shout loud teachers, it's going to go, whoa, I was looking for a string. You gave me an array.
Well, no, stringify it first. In the map.
Ooh. So if I say loud teachers dot map loud teacher I shout it, then I'll bet that works. Let's take a look. There we go. Well, wait a minute, we just talked about this. Maps are for transformations. I'm not returning anything, ergo I'm not transforming anything. So, what gives? What should I be using instead? I like the overall shape of this, but I don't think map is the right one.
Or each.
Ooh. And does it work? It works. So, the thing I want you to take away from that, for each is 4 side effects. If we're doing a bunch of side effect shit over at a list, for each is probably the right thing to do. All right, I see another referential transparency opportunity here. Something about these two. Because I have a declared variable again.
You can chain for each to the map.
Hell yeah, I can. All right. So now, do I have any declared variables other than these? Nope. Do I have any immutable state? I do not. Do I push side effects to the end? I do. Are all these functions pure? Yes. Am I using anonymous inline functions? We're using this one.
You're also using one for each, right?
Oh, yep, that also. And with both of them, I can do the same thing to get rid of those. And this is a pattern that, like, you got to get real used to spotting as a functional programmer.
Turn them into functions of their own.
We could
Couldn't you
take a look at what they're doing.
So like, it's just doing Loudify, right?
Yep.
So you just map, and then you just have Loudify in there.
Anytime you see that pattern, I have a variable here, and then all I do is have a function that passes that variable in. Every time you do that, you can replace that with that. Does the exact same thing. So then in for each, same thing. I have a variable. All I'm doing is passing that variable into another function. Fuck it. Does it work? It does.
That's crazy.
That's my favorite thing I've heard all week. Thank you. It is. That's how that would look functionally. That's how it would look functionally in vanilla. I'm going to show you one other way. That's the way that I would do it. But questions about this so far?
So the way that mapping for each works is because, like, we map the block or whatever it is called in JavaScript, because that's all you're
Function.
really doing is you're just like passing that function into another function. It like automatically decides like what function you're passing in there.
So, let's be real clear on this. That dot map loudify, let's like tear that apart a little bit. Referential transparency. All three of these are identical. They do the exact same thing. Map takes in a function definition. So we can declare it in line with that syntax. We can declare it in line in this syntax. Or we can save it in a variable and then pass it in that way. They're all equivalent.
Oh, because what map is doing is taking each string in the array, and because we already have an argument of string and modify,
Right.
it's okay.
Yes. My favorite sound as a teacher.
I misunderstood math like from day one until just now.
That's not uncommon, because on day 2 when we're going over Haskell and I show you map, I can't go, well, see, map is an applicative that borrows some functional programming and it applies a function to each member of an, like, no fucking way. Now's the time to understand what it actually does.
Could we also then change our shout and our modify and make them small? Since it's taking in a string and just console logging that string?
Oh, just inline them?
Yeah.
Yeah, we can do that. Can't say it enough times. This takes in a function definition. This is a function definition. This is a function definition. This is a function definition. That's why we can do that. Cool. I want to show you the way that that I would do this. It's fundamentally going to be the exact same thing, but it's going to look substantially different. So I'm going to use a library called Lodash. So if I make an npm project, npm install Lodash. You don't have to follow along with this. I'd actually probably recommend not, but I'm not your boss. So, all right, I've installed Lodash. And then if I'm going to destructure some things out of it. First one I'm going to get is one called flow. I'm going to take it from Lodash/FP. Lodash has a functional library. Works just like Lodash. Has all of these exact same utility functions. It's stuff like there's a map in here. Does the same thing as regular JavaScript map, except it also works on objects. It also works on strings. It works on anything that could be classified as a collection of different things. So a lot more like the one in Ruby. And so we have stuff that we've already had. We also get cool shit like order by, where order by will take like an array of objects, and then you can just pass it a string, and it will sort everything by whatever key that matches. So just tons and tons of these teeny tiny little utility functions. And they have a part of it called FP that is a functional version of every single one of those. And I'll show you what that ends up looking like. And like when I learned this, my heart soared. So functional programming is all about visualizing a program as a flow of data changes. Flow is my favorite tool they have in here. Flow takes in two things. It takes in an array of data, an array of function definitions and starting data. So I might yank that. So right off the bat, it looks a little bit different. Anybody remember the vocab word for when we take a function and invoke it a bunch of times like this? Currying. We curry it. The first time we invoke it, it's going to expect an array of functions, and the last thing it's expecting is the data that's going to pass into each of those functions. And then for each one of them, this is the starting input to whatever function definition I give here. The return of that is the input to the next one. The return of that is the input to the next one. And the return of the last one is whatever this evaluates to. All right, so first thing that I want to do is I want to map over each of these. So I need the map one. I was okay. Well, what is map doing? Well, it's loudifying. So I'm going to borrow these. All right, so I want to, this is my first function definition. Unlike array.prototype.map, this doesn't actually invoke it. This is a function definition. And it's going to invoke it with this data. It's going to take the return of that and pass it to the next thing. So I want to, I also want each, I'll do each shout. And right off the bat, this should work. Let's see if it does. It does. So I can further functionalify this by making a loudify all that does exactly this. Is map Loudify. And I can have a shout all that's in each shout. And then these become Loudify all and shout all. So let me be real clear about what happened here and the reason why you would organize your code this way. I took these teensy tiny functions like map, shout, loudify. I recombined them in different ways. And then this reads like a little story now. We take in this data, we loudify all of it, and then we shout all of it. That's the like super functional way to do that. Still fundamentally the same thing as the old one below. But we curry the functions and we pass the data in last. Questions? Yeah, Ness.
Why would you use this versus vanilla JavaScript?
Sure. I'm going to reach for Lodash basically anytime I'm doing data transformations. There's so many fucking good ones. Here's another cool thing you can do with map. So a really common pattern is I have some data and its array of objects, dogs. And Mace has been dead a very long time, and Bixby, for that matter. They're my old dogs. She's probably 20. So, all right, so these are my dogs. Let's say I want to just get the names. And so with regular map, I go dogs dot map dog dot name. That is like bread and butter vanilla JavaScript. We do that kind of shit all the time. Now I have an array of names. The Lodash way to do that would be to do map name dogs. Ugh, beautiful. So much more expressive.
Why is name a string instead of a symbol?
Because this is one of the wild things we can do with Lodash's map that we can't do with a regular JavaScript map. It'll take in a function, or if you give it a string, it goes, I get it. You want to pull that key out of each of these. Done.
So it compares the string to key names?
Yeah. So if I have to do a bunch of data transformations, I am reaching for Lodash. There's a couple of these. Ramda is another really popular one. But something like, I used chunk recently on something, which is like you take an array and you say how big a chunk you want to make out of it, and it splits it into smaller arrays that are each that size. Or, let's see, intersection. So this is like set math. I want to take two arrays, and I want a new array that has all the ones that are in both of them. That's a math intersection. It is awesome. And it's exactly the kind of thing that you could totally write by hand, but A, you're probably going to miss some weird corner case on it, like, oh, what if it doesn't get past the right data type, or what if the shit's empty, or something like that, that won't work the way you think it will. And also, all of these kinds of things in every language are solved problems. Stop writing this shit yourself. Somebody wrote a faster, more efficient, handles more corner cases version of it. Just use theirs. And so, like, when I was working on that calendar app, where I needed to like combine all the different availabilities together, intersections for days. Yes. So let's say I pull in I'm going to pull in intersection also. And I do something like intersection one, two, and then I want to intersect that with this one that just has 2. So I should get a single array back that says 2 because that's the intersection of those. Well, another one here. It's the intersection of those 2 arrays. So like, hey, why don't I use my shout? Shout, all of that. There's the intersection. You can also do that with arrays of objects and whatever else. Super powerful. XORs, that's like Boolean math. All this like little tiny stuff. Find the last match. Find does the first match. If you need the last one, you've got an option for that. For each write is a for each that starts on the last element and works backwards. Reduce write, so does the same thing, where it reduces in the opposite direction. You can imagine something like division, where order matters, where dividing something sequentially in one direction versus doing it in the other gives you very different results. Sample, this is a way we can do randomness. So if I give it an array and I want a random element of that, I can just use sample. Some is actually built into JavaScript now. It's pretty powerful. This will tell you whether or not at least one element in an array matches some condition. It just returns true or false. Really helpful for something like filter. Debounce. This one's fucking awesome. This makes it so that you can only call a function so many times in like a period of time. So let's say you're doing something like capturing user moving their mouse. Okay, well that's going to capture like a mouse move like several times a millisecond. You go, it doesn't need to be that accurate. Once every 10 milliseconds is plenty. You can debounce that so that it only actually fires that event off every 10 milliseconds. It's debouncing.
So is this keyword the opposite of functional programming?
Yes, there's no this in any FP language. This is a like down and dirty OOP, like to the bone concept. Memoize, this is another like super functional thing. Memoizing is if we have these pure functions where we get the exact same thing every time we call them, do we need to do the calculation every time then? You could memoize a function so that I go, all right, well I gave you these arguments and you generated this output. Why don't you save that? So if you see these same arguments again, just give me your saved value instead of actually doing the calculation. Really common example of that is Fibonacci sequence. So your Fibonacci sequence, as you might guess, gets more and more expensive to calculate, like exponentially each time. So your computer will usually crash around like 40 or so. Because that's so many calculations it needs to keep doing, unless you memoize it. And then it gets a lot easier and you can go much, much higher because you've cached the previous ones that you've done.
Every time you say memoize, it sounds like you're trying to say memorize.
Memorize.
Mewage.
Mewage. So no, the idea of the reason it's a memo is when you call the function, it looks at the arguments and then it looks for a memo that it gave itself. It's like, has I ever been given these before? I was, and this is the thing I output. So I'll just give you that.
So it's cheaper as far as computing power, but it takes up memory.
Correct. And that is throughout computer science, those two things just trade off. If it's cheaper to calculate, it's more expensive to store. It's cheaper to store, more expensive to calculate. It's like fundamental law. Clone, or clone deep. Holy shit, this one is pulled me out of a lot of things. So this is like basic JavaScript shit. But if I make an object, this is like exactly kind of shit they give you in code challenges too. A and B refer to the same thing. Not like I just made an empty array. Also, if I do B dot sum key equals high, A dot sum key also equals high. They refer to the exact same thing in memory. It's called a reference type. So if I did actually want to make a copy of this, that's surprisingly hard to do. So the cheapest way, this is the way that most people do it, is if I want those to be different, I do json.parse, json.stringify. If I turn it into a string and then parse that string, I've effectively made a copy of that object. There's gotchas on that though. If you have methods on there, you can't really stringify a method. And so like that doesn't work quite as well. So way better. Why don't I just use, why don't I just use deep clone? Does the same thing and describes what the fuck I'm doing. So if you don't know that JSON parse and stringify trick, you're gonna go, why on earth are you doing that? I'm making a copy. Cool. Anything else? Thank you.
So when's the Lodash class?